No two human bodies are alike, and it seems strange that there is a lack of science that focuses specifically on how to optimize each individual's strengths. This is important in the forces, where a small difference in performance can be absolutely crucial. Daniel Kraft is heading to Massachusetts to investigate.
For anyone who's been in the military, being in a combat zone is bad enough without also having to fight the elements. I just arrived and I'm already soaked to the bone. This definitely sucks. The only good thing about this, however, is it's not real. Okay, guys, that's enough. I'm in a specialized weather tunnel at a U.S. Army research facility in Natick, Massachusetts. It's where they design, develop, and deploy the best gear for soldiers. It's also where they test it out.
This rain chamber can drop over 3 centimeters of water per hour, which is like a hurricane downpour. Every year, soldiers come here to be pushed to the limit for month-long tests in the most extreme conditions the world has to offer. Wet. Hot. Cold.
We have a tropic chamber and an Arctic chamber. The tropic chamber has the capability to go to 140 degrees Fahrenheit, and the Arctic chamber can get down to minus 70 degrees below zero.
The point of these test chambers is to measure how each individual responds and to send that data to engineers who design the gear these men and women need for combat. And it all happens under one roof. This one.
We're going to put a typical soldier's combat load on you, just so you get the experience of what it's like to be a soldier out in a deployment.
All right, let's do it.
This is just a small abbreviated amount of the actual kit a typical combat soldier would wear while deployed to combat area.
All right. All right.
So we're going to put you in the tropic chamber, and we're going to put you on the treadmill and give you a workout.
It's hot and I'm already feeling heavy, so it certainly feels tropical.
It's about 106, 107 degrees in here. Relative humidity is about 45%.
So Sergeant Adams, is this pretty realistic?
This is pretty realistic, sir, in terms of, say, the temperature. But once again, you're very light right now, sir.
This is light, okay. And I'm not being shot at.
I'm wearing 40 kilograms of gear, which apparently is on the light side.
Okay, so we started up, and it's a nice day for a walk. Left, right, left.
The point of the test is to monitor my biometrics and see if there's a way to make me perform better in this extreme environment. The lights above me imitate actual sunlight, and the treadmill simulates the kind of endurance needed for a typical exercise.
So let's give him a little more speed.
Sure.
Woo! All right, amp it up. This is the best you can do. Come on.
All right, go ahead and pick it up just another notch.
Hey, how you doing, sir?
Are we there yet? I think we're getting close. We're getting there.
All right, let's bring him in and bring him down.
Okay, guys, I'm coming out.
The computer measures my ankle, knee, and hip joint rotations. It also measures how much oxygen I'm taking in and the CO2 I'm letting out. Adams compares my body's reaction with other soldiers. A database averages the results. The performance tests reveal that some current Army equipment could benefit from significant weight redistribution. I need to go to another lab to find out whether we can fix the problem. It's easy to have fun inside, but in the field, it's a matter of life and death.
A U.S. Army facility in Massachusetts is engaged in a groundbreaking study of how the human body bears weight and how their kit has to be adapted to keep men and women on the move and alive. This research could be the key to optimizing physical performance in the future.
Daniel, welcome to the Center for Military Biomechanics. We conduct basic and applied research projects to evaluate soldier or human performance and soldier-centric products. What I specifically work on is trying to optimize load and how you configure the load and makes them a better athlete, so to speak.
I've already discovered that my gear distribution needs to be adapted for my body. Now it's time to take a closer look at how I move and how the things I wear need to be outfitted. And that means motion capture.
I realize you have to change a lot around this place.
Yes, all right, so first thing, if you just grab a seat right there, we're gonna mark you up. Shout that.
So what are the cameras actually seeing when I'm wearing these dots?
Good question. So if you look at this camera over here, you see there's the lens, and around it, there's the white circle. So those shoot infrared light. The infrared light bounces off anything reflective, i.e. the reflective tape wrapped around the ball, and the infrared light goes back to the camera. We're going to put some soldier equipment on you and have you do a few motions.
I'm ready.
Okay.
No, this is definitely lighter, yep.
First thing we're going to do is check or test how well you accelerate with the load. So what you want to do is walk. I want you to plant your right foot right here and sprint out.
Okay, got it.
Go ahead.
All right.
Good job. What we just captured was your walk to run transition. So trying to figure out how carrying weight slows down your ability to accelerate from a walk to a run. So you can see you start walking in the capture volume. Your right foot is the orange one. You're gonna plant on your right foot and then run out of there.
And you're measuring the force.
Yep, so you see that red vector that comes up?
Right.
That's the force vector. So that's how hard you're pushing down on the ground.
Amazing.
So now we're gonna add another 20 kilograms.
And now we're gonna try running this again. I'm still dotted up, and rock on.
Ready, Daniel? All right, go ahead.
All right.
All right, good job. Go ahead and come back.
So what are the differences between the second run where I'm wearing another 20 kilos?
You're gonna have a greater forward lean. You're gonna bend a little bit more at the trunk. You're gonna have greater hip and knee flexion, kind of lower your center of mass to increase your stability, because with all that weight, you're probably more likely to tip over, less stable.
And when do you see this sort of emerging outside the lab?
I think in the next year or two, we'll be able to actually measure somebody's joint kinematics, their trunk lean, knee angle, out in the field with the wearable device.
Tyler's test shows me exactly how my body performs and how it's different from other subjects. The graph shows a sharper spike with a larger load. By studying the precise changes in performance with different weight distribution, Tyler can input new data to adjust the load. The facility here has now tested thousands of people in order to create the profile of the perfect soldier. And that's certainly not me.
Thank you, it's been fun. You wanna try the heavy backpack now?
Heavy one? I thought this was the heavy one.
Follow me.
Oh, man.
This military research has civilian applications. A wave of new technologies are on the rise to quantify the self, measuring all the individual aspects of our body's performance, which enables tailor-made improvements. It's a concept that millions are now embracing in their everyday workouts. And if these precise changes can make me run faster, climb higher, and be stronger, I'm in. The last step is to meet the engineer who looks at all this data to build the ideal kit.
We design all of the load carriage structures that support the modern soldier. Let me show you the newest backpack system that we've fielded. This is called the Molly Medium system. It's got an ergonomically shaped frame that supports on the torso either with or without body armor. And all of the locations of webbing, we tied into the specific pocket designs.
So where do you see this going in the future?
Well, a lot of it's happening right now. You know, the critical piece on the soldier's load is tying in the ballistics to the fighting load and to the larger sustainment package. It's critical. But probably in the next 5 years, we're really going to be able to focus and bring it all together so it's a real kind of a unified system, a little more seamless, if you will.
By 2018, the researchers and designers at Natick expect to outfit a new generation of soldiers for combat in gear that is lighter, sleeker, and safer.
The U.S. Army has taken a very thorough approach to evaluating human performance and custom designing gear all under one roof. A belief in the idea that small improvements in a number of areas can lead to a marked improvement overall. The civilian applications of this program are wide and numerous. The more precise the understanding of the human body becomes, the better scientists can design new technologies to adapt it to a changing world. It's obvious that humans will continue to perfect and enhance themselves with technology. That may even lead to a radical leap, where people might replace perfectly functioning parts with better, artificial ones. Cyborg limbs, bionic eyes, enhanced brains, kit that makes people stronger. It's not science fiction. It's all already real, and it will be a critical part of our future. Thank you for watching.